Dear students, welcome back to my session on the analysis of indeterminate structures. We are going to start with the first module. The module is Slope-deflection Method. So in this session, we are going to see how this slope-deflection method can be used for solving indeterminate structures. What I mean by indeterminate structures? Structures like continuous beams. This is a continuous beam. Or frames. This is a portal frame or any type of frame like this, a T-frame. So such structures we are going to solve using slope-deflection method. So first I am going to give you the equations of slope-deflection method. The equations are written for each member. Two equations are written. Before that, you should understand what we are going to find in slope-deflection methods. In slope-deflection method, the primary unknowns are displacements. What I mean by displacements? Displacements are nothing but slopes or deflections at the ends of the members. So these are primary unknowns. Slopes or deflections. I hope you know what is meaning of a slope and deflection. You have studied already in strength of materials. Slope at any point and deflection at any point. Now let me write down the equations of slope deflection. So the equations of slope deflection are written. They are very important. Let's note down. MAB is equal to MFAB plus 2EI upon L into bracket minus 2 theta A minus theta B. MBA is MFBA. I will explain this. What is meaning of each and every item here. Minus 2 theta B minus theta. These are the slope deflection equations. I call this as equation 1 and this equation 2. And these equations are written for member AB. Similarly, you can write for member BC, MBC and MCD. You can write for member CD, MCD and MDC. So here, what is meaning of MFAB? Fixed end moment for member AB at end A. Fixed end moment. I have given the formula for fixed end moment in the last session. 2EI upon L. E is Young's modulus, R is moment of inertia, and L is span of the beam. Theta A and theta B are the slopes at ends A and B respectively. So this is what is MA. And MBA is similarly like this. MFBA, fixed end moment at B for member AB. Again, E is Young's modulus, R is moment of inertia for member AB. L is span, theta B is slope at B, theta A is slope at B. So these are the slope deflection equations. And the sign convention that I am going to use is, I have already mentioned in the last session, but again I will mention, sign convention, anti-clockwise moments are positive. Anti-clockwise moments are positive. Keep this in mind. And clockwise slopes or rotations. Slope and rotation, what I say? Rotations are positive. That means whatever sign convention I have for moments, the exact reverse sign convention for the slopes. So these are the equations. Now let me take up one example so that the things will be very clear to you. I have given you a PDF just now, and there I have given the entire procedure of solving the problem. So you have to go through that first and then come back to this video. So now I am going to take one problem and let us see how this problem can be solved using slope-deflection method. It's going to be very interesting. So I have just taken a problem and I have solved it, and you also can understand it now. So this is a beam. First problem of slope-deflection method. This is a beam. Okay. So this is support A, support B, support C. So what type of beam it is? It is two span continuous beam. This end is fixed, this end is hinged, and the last end is a roller end. And loading is like this. concentrated load that is acting 30 kilonewton, 30, and there is UDL, which is equal to 15 kilonewton per meter. So these are the loads that are acting for AB and BC, two span continuously. And moment of inertia here is I, and moment of inertia here is also I. Now what is missing in this problem? The data that is missing is the span of the beam. So we should give the span also. This is 4 meter from A to this node, and this is 2 meter. That means the total span is 6 meters. And the span for BC I will give again as 6 meters. So this problem we have to solve using what I should say, the slope-deflection method. Now first step is primary unknowns. How many primary unknowns? Primary unknowns are identified at the supports. So this is fixed end, so there is no slope, there is no deflection, because fixed end will not have any slope and deflection. This is hinged end, it will have deflection, so it will have slope, and this is roller end, it will also have slope. So deflections are not here, only slopes are there for B and C. So the primary unknowns are theta B and theta C. The primary unknowns are theta B and theta C, because theta A is 0, fixed end. Theta B exists because it is a hinged end. Theta C exists because it is a roller end. So only two primary unknowns. So these two primary unknowns we need to find out. Now let us first write down the fixed end moments. You know, I had given you the formula for fixed end moments. Now I am going to write down the fixed end moments. That is the first step. What are fixed end moments? Fixed end moments are the moment developed at the ends due to fixity. That means we consider span AB as fixed beam and find out the fixed end moment. The formula given. The span BC as fixed beam and find out. So the formula that was given in the last session, I am going to use them now. MFAB. What is the formula? Anti-clockwise is positive. Here the fixed end anti-clockwise plus W. A is 4 meters. B square upon L square, 6 square. So when we do this, fixed end moment MFAB is WA B square upon L square. It comes 13.33 kilonewton meter. Then MFBC, sorry, not MFAB is over, now MFBA. MFBA is minus because this is clockwise and our clockwise sign convention is negative. Minus W B A square upon L square. What is A? A is 4 meter, B is 2 meter. So this comes minus 26.667 kilonewton meter. This is fixed end moment for member AB, that is MFAB and MFBD. Now I will write down MFBC. What is the formula for the fixed end moment when UDL is there? WL square upon 12. So MFBC is plus WL square upon 12. W is small 15, that is UDL. L is 6 square divided by 12. So it comes to 45 kilonewton meter. Similarly, MFC minus WL square upon 12 minus 45 kilonewton meter. So we have found out fixed end moments now. Now what next? The next step is we should write down the slope deflection equations. How many slope deflection equations? 4. Why? Because 2 members. For each member, 2 equations. So I am going to do it now. Just see how I am going to do this. Is very important step. Slope deflection equations using the formula that are given. Now what is the first equation? MAB. MAB is MFAB plus 2EI upon L minus 2 theta A minus theta B. This is the equation of slope deflection. Now let us substitute MAB. MFAB we just found out. How much is MFAB? 13.333 plus 2. E is E. I is I. Span for AB. How much? 6. Minus 2 theta A. I have already told you theta A is 0 because it is fixed end. Fixed end there is no slope. So minus 2 theta A becomes 0. Minus theta. So when you simplify this, how it looks? 13.333. 2 by 6 is 1 by 3, that is 0.333. So minus 0.333 EI theta. So this is my equation 1. Now similarly I will write MVA now. MVA, what is the formula? MFVA plus 2EI upon L reverse minus 2 theta B minus theta A. It was minus 2 theta A minus theta B. Here it is minus 2 theta B minus theta A. MFVA becomes MVA. So MVA. So what is MFVA? We have already found out MFVA, which is equal to minus 26.667 plus 2E. R is I. L is again same member 6 meters. Minus 2 theta B minus theta A is 0 because it is fixed. So when you simplify this, what you are going to get? MVA will be equal to 20 minus 26.667. 2 by 6 is 1 by 3 into 2 is minus 0.667 EI theta. So this is my second equation. So I have written two equations for member AB. Now similarly, I should write quickly another two equations for member BC. So let me do it here quickly. MBC. MBC is equal to, what is the formula? Can you directly write? The formula is MBC, and write the formula MFBC plus 2EI upon L minus 2 theta B minus theta C. You need not write always the formula, you can directly substitute. So MBC. MFBC we have found out. What is the value of MFBC we have found out? It is equal to 45 plus 2E. I is I. L for BC again 6 minus 2 theta B minus theta C. So when you simplify this, it becomes 45. 2 by 6 is 1 by 3 into 2 is 4 by, that is 0.667 minus 0.667 EI theta B minus 0.333 EI theta C. That means just you have to simplify this, that's all. So this is your third equation. Right? Now the fourth equation. Fourth equation is MCB. Last. MCB, what is the formula? MFCB plus 2EI upon L minus 2 theta C reverse minus theta. Let us substitute now. MFCB, how much is MFCB? We know it is minus 45 plus, so plus 2. E is E, I is I, L is 6 meters again, minus 2 theta C minus theta B. So quickly let us simplify this. MCB becomes how much? Minus 45 minus 0.667 EI theta C minus 0.333 EI theta B. That is just simplification of this. This becomes equation 4. So 4 equations we have written. So dear students, have you understood how we have written all the 4 equations? For each member 2 equations, and we have substituted the values. Now having done this, the very important step is, if you look at all these 4 equations, how many unknowns are there? Only 2 unknowns. What are those? EI theta B and EI theta C. So how to solve these unknowns? How to solve these unknowns? We have to write down joint equilibrium conditions. What are joint equilibrium conditions? Joint equilibrium conditions. What is at joint B? There are two members BD, BA and BC. So the moment of MBA should be negatively equal to moment of MBC. That means the first equation is MBA plus MBC equal to 0. That means whatever moment at B is there, MBA should be negatively equal to MBC. That means MBA plus MBC equal to 0. Call this equation 1. Second equation, if you look at C, it is a roller hinge stand, so there is no moment here. Because it is a roller and a hinge stand, and there is no continuation of the member. So moment at C equal to 0, or nothing but MCB equal to 0. This is the second equation. So these two equations you have to solve. MBA plus MBC equal to 0. Already MBA I have given to you. You have already found out what is the value of MBA. MBC you know. MCB also you know. You have to solve these two equations. First simplify this equation and then take this equation. Solve these two equations using your calculator. Simultaneous equations with two unknowns. Once you solve, you are going to get the values of EI theta B and EI theta C. So I have found out the values of EI theta B, which is equal to 34.96, and EI theta C is minus 84.92. Plus 34.96 means what? Theta B is positive. What is positive? According to our sign convention, it is clockwise. Clockwise rotations are positive. And here theta C is anti-clockwise because it is negative. But whereas moment sign convention is reverse. Clockwise is negative, anti-clockwise is positive. So we have found out theta B and theta C. After finding out theta B and theta C, what you have to do is you have to go to that main four equations that we have written, slope-deflection equation, MAB, MBA, MBC and MCB, and substitute the values of EI theta B and EI theta C and get the final moments. The final moments will be like this. MAB will be equal to 1.69 kilonewton meter. MBA, we check out the answers, minus 50 kilonewton meter. MBC equal to plus 50 kilonewton meter, because both have to be same. We have substituted MBA plus MBC equal to 0. That means MBA and MBC should be equal and with opposite sign. 1 minus 1 plus, and then MCB, you will come. You have substituted 0, you must get 0. So this is how you find the equations, find the moments and the x. Once we find the moments, we have to draw bending moment diagram and shear force diagram. So first you go through this, and then I will explain how to draw bending moment diagram and shear force diagram in the next session. I hope you have understood this. You should very clearly understand what I am going to do here. It's very simple. First, you have to write down the slope deflection equations, and before that you have to identify primary unknowns, and then solve the equations, find the joint equilibrium conditions, solve and get the values of EI theta B and EI theta C, because these are the primary unknowns. Substitute them back in all the four equations, you are going to get these values. And once we get these values, we will see how to find out bending moment diagram and shear force diagram, because that is the final answer. Is that clear to you? Okay, go through this, and I will pause here and we will come in the next session.